Hello, I'm Matteo, the lead quant researcher at CrunchDAO, and today I will present you the science framework we developed for our decentralized autonomous organization. This video is going to be in between a presentation and a tutorial. I'd like to go in detail into the implementation choices we've made up to now and what we have now that you can already use. So you see this paper is the outcome and the description at the same time of the framework we've developed. And it's living in our website at decentralized.crunchdao.com. And you can already see there's a commit hash and an IPFS hash. But one thing at a time, I would say. So it's worth mentioning that this is part also of the 15th round of Gitcoin, the first one including decentralized science in it. And so it's an exciting moment to see how the technology and also the market, the culture is shifting towards understanding the need for the use of these technologies in meta science. Yeah, I mean, I guess we can go into the details later, but a bit about the content of the paper already is the fact that DeSci aims at solving a number of problems, what's called the tragedy of anticommons, and then the ability to overcome the limitations of peer review. And also, in some sense, take all the lessons learned from open science, but overcome the limitations of some assumptions in open science and open source software. But yeah, I'll go into these details once we, let's say, we are able to produce this paper on our own. So let's say a normal user would go to our GitHub repository, an external user, so a member of the DAO or a wannabe member. We'll go into this repo. It's at CrunchDAO in GitHub, and you see we have a number of repositories, and this one is DeSci. It's basically a combination of a Python package and a paper repository, which allows us to have a living organism, a living scientific unit of knowledge. So let's say a paper, but we want it to be more than that. And the idea is to integrate it tightly with the Python script or whatever language you're using. In this case, we go with Python, which is the language used in the backend to populate the content of the paper. So the figures, the statistics, the results, so numbers. We want it to be transparent and so reproducible as much as possible, so that we can quickly avoid reinventing the wheel, which is exactly the tragedy of anticommons I was mentioning. But also be reproducible. So yeah, it's a Python package, and it's using a template, pretty common. You can both install the package with pip and with poetry. But yeah, I would say one thing at a time. Let's go forward and install it. So we can start cloning the repository in our editor. In my case, this is VS Code, and we can clone the repository, which is already public, of course. Now let's enter it from VS Code as well. So we can go in CrunchDAO, DeSci. Of course, I have already an old repository, but I create a new one just for showing the experience of the new user, let's say. And so we are into this repository. We can first of all create a virtual environment. We are on Python 3.9 currently. So we can create it, and then once it's created, okay, yes, but source vam bin activate, and we're inside it. Now, as I said, it's a Python project, so we can install all the dependencies going here, but I prefer using the makefile. I mean, there's some installation steps, but I guess since there's a makefile, it's probably better to install it using make. So we start installing poetry, which is gonna create our environment. And then we can install all the requirements of the package, including the package itself. So now the package is really basic, it's minimal. There's a couple of example commands with a command line interface. The idea is, though, that we can integrate these figures and results and codes inside the paper itself. What else is worth mentioning? Here we have the pre-commit, which allows us to have everything clean up. I guess it's in code style. Yeah, actually we use this when you push. So not much to mention beside this, let's say. So while this is installing the requirements, I will show you the part about paper documentation, let's say. And so there's a folder on the left which contains some figures which we're using to populate our paper, fonts, then some scripts, and most importantly the template that we got from GitHub, a public project. And this template is a LaTeX file, but our goal was to remove the need for people to write in LaTeX as much as possible, so that the LaTeX template is called only by the action, and I'll show you what I mean by action, producing the paper. So this is a template we choose just because it was good looking. Of course, this is also open to improvements. But the core of the work is living basically in this markdown file. So we follow markdown is, oh sorry, I opened the HTML. We used markdown because it's really easy to write, and it can be used as an input to LaTeX to populate scientific objects. So without digging into the content, you can read it, of course. I'll link it in the description of this video, and it's also, as I said, in the website. What we can do here is that on the one hand, we can, now that the package is installed, is that we can run dci. Let me do this and run help. You see there are two commands for this command line interface. The first one is the hello world. Okay, it's not the first one, but it's the easiest one, and it's simply printing hello world in the terminal, so it's not doing anything else. The hello plot command does something more fancy, which is simply producing a plot, a basic plot, that then lives in this folder. So if I delete it and I run this hello plot command, you see that hello plot comes back. So there's a script producing this. Of course, one could be interested in defining new commands, and this is easily done, modifying the command line interface file here. And so if you want to have another line here, for example, and you want to say this line was produced during the video presentation, you save it, and then you can reinstall the package without going through make. I mean, I guess the time it takes is the same, given that the requirements have already been installed. But now you see that the commands are the same, and I can run hello world, and you see that this line was produced during the video presentation. So that's cool. Imagine that we're doing some kind of optimization, and we want to modify some parameter, we want to change the optimizer, or we want to use different data sets, and so we can modify the script and produce it, and use it to produce outputs that are then used to populate the object we use to communicate what we did. And this is the paper. So it's written in Markdown, as I said. Once we are done editing the video, the paper, and maybe I could give you an example of this, and we could simply add something here, someone, something, something else today. So this is not currently online, as I can show you here. You see that there's just 2 contributors. But now you see that since we have associated this repository with our website, and given the number of GitHub actions we've written, now I don't want to go into detail, but we have a Docker image producing our paper in PDF, and potentially we can have multiple formats. And the power of this is outlined in the fact that we can include even animations in our communication. But yeah, so you can see that if I want to push these modifications, and what's going on? Yeah, of course I modified also the command line interface. So let's add everything. So we have a feature, differently command, and test contributor. We can push, and you see that this push is now here 11 seconds ago. You see there's an action. This action can be seen here. We have two different actions every time we push. The build action, which is going to check for consistency in the code format, and you see it's installing Python 3.9, poetry, all the dependencies, some style checks, the tests associated with the script. This is all pretty standard in Python. For the decide step, though, we have a number of steps, the most interesting of which is the build of the PDF. Also HTML, that's actually a goal. We still don't have it in the action itself, but we can produce a PDF. This PDF then is in real time rendered on our website. So it still takes a minute to build this Docker image. It's pretty heavy. We're working on making it lighter, but nevertheless, we have an action that once it's done gives us, and sorry, now I cannot see it, but gives us an artifact. This artifact is the PDF version of the paper, which is associated with this exact commit. So you see this hash here is C5E37. Here we had a previous commit on the paper, and I guess now we can close the GitHub. And now you will see that the commit is pointing to the last commit we did. So there's C5. This is the last version of the paper. And in fact, you see that here there's the modification we did together. There's a typo, okay. But okay, so this is the paper. We tried to populate as much as possible the environment in which this work came out of. So Decentralized DSI Labs is the main example. Their DSI node and the collaboration we had in the last few weeks. Also worth underlying the protocols and software developed by open journals and their application in the Julia ecosystem. Then some literature and similar experiments in the use of Web3 technologies for scientific publications, so for meta science, let's say. Yeah, I won't go into the detail of the design choices. I guess it's worth for you to take a look. The coolest thing is that once we are able to produce the HTML version and not only the PDF, which can have its benefits, we can remove some limitations of using PDFs. An example is having animations. And so we have this HTML pointing at the last HTML in the GitHub repository, which is not yet a GitHub action. But still, you see how cool. We can have something like this in a paper. And everyone can contribute to it. That's the power of it. And we are trying to build the incentives. I mean, in CrunchDAO, the incentive is kind of implicit, but every organization, in particular if it's decentralized, but I would say every organization, even universities, could make use of something like this to be able to manage a diverse ecosystem of contributions and to integrate them and to make them dialogue, which also means fight, of course, to arrive at a conclusion. And so this fact that one can criticize the paper is in line with the idea of science being falsifiable, and the technology resembles this. What else? So the last thing I'd like to talk about is IPFS. In fact, this framework can be used for a bunch of parallel avenues not explored directly in CrunchDAO, but we underline those. And for example, the implementation of an incentive structure for micropublications, for retroactive payments, and also, for example, here we mentioned DSI words and their study of NFTs for science and intellectual property. An idea could be to associate to this immutable version of the paper with something like a patent. And this has to be explored. We're not focusing on this, but we are, I guess, supporting it. And so the GitHub action we have, and we have a different GitHub action that mirrors basically the evolution of the main branch of our GitHub repository, living on the interplanetary file system. This is done via an action, which is here. Sorry, not here. It's the upload PDF to IPFS. It was an existing action on GitHub, so credits to the developer. But we're using it basically, and you see that this hash is the same as the one we had we have here, and then I'll show you how to go back to the website. And you see there's the modification we did just now. This hash is here. You see BA is the same as the one we have here. This can also be found using some IPF browser, and you can see that you go here and you see it. And another interesting way to show, I think, is using the terminal. I don't know why, but I like using IPFS with the terminal. And you see that you can, okay, I think I have already initialized it. Yeah, so we simply have to start the daemon. And sorry for the pronunciation, I think you have to say daemon, I don't know. But okay, now that's ready. We can move and get what we have. And sorry, I missed get. And so we save the file, which is now in our laptop. So you see here we have the paper, which is the version we're interested in. And we can do even more. Let's say we're interested not in the last version, which is the one mirrored in the website, but we want to go backward to a previous version. So let's do it. Let's look for, instead of this one, let's look for the one I just done before the recording, correcting for colors. And let's say we're interested in this version of the paper. We have another IPFS link, and we can do the same, sorry, from the terminal. I mean, we can do it also from the website, but as I said, I like the terminal. And we can run this, and you see that the hash is different. Kind of similar, but different. And we can go here. We have now two repo. I have to check which one is the last one. TA is this one, not the last one I downloaded, but the previous one. And here there's no contribution. And so this history is living on IPFS and is accessible. So this is it. I hope you find the project interesting and useful. I hope you use it both as a member of the CrunchDAO, but for different projects. For example, now we have a number of works that came out recently. You can find them here, by the way, on machine learning, dynamical systems, applied to finance, of course, given the field the CrunchDAO is moving in, but also astrodynamics. And we're going to use this framework to work. So I'm positive that there's some value in it even outside CrunchDAO, which is the reason why we framed this decentralized science framework by CrunchDAO and not only for CrunchDAO, even though CrunchDAO is the most natural user. So for everything, you have the GitHub of the organization, my personal GitHub. I think it's, yeah, you can arrive there. Feel free to jump on the CrunchDAO Discord, to connect with us on Twitter, LinkedIn, and yeah, let us know what you think, both of the framework, of the content of the framework, and yeah, everything. Thanks a lot.